All right, for our drawing today, you're going to need the small protractor and a ruler. We're going to start with the top drawing. We have an incident light ray coming into a block of glass. And the first thing we need to do is draw a normal line along here. Now the normal line is perpendicular to the surface, so I'm going to line up my protractor with this point of the intersection of the incident light ray and the surface, and right at 90 I'm going to make a little mark, and then I can use my ruler to draw the normal line. Now the purpose of the normal line is to measure your angle. So we're going to measure from the normal around to the incident light ray. And this is going to be the angle of air, the incident angle. All right, so we'll put our protractor up here. I'm going to start with my zero line on the normal line. And we're measuring around this way to our light ray. I'll let you get caught up here. Actually, how about we'll do a pause and measure. All right, so we all have the same measurement. We're going to start with 42 degrees. Now this is the incident angle, and that light ray is going to bend when it goes inside the glass. So we're going to calculate the refracted angle using Snell's law. And again, we're going from air into glass, so I used A for air and G for glass in my formula. We're going to find the angle in the glass, so we're dividing by n for the glass, and we're going to do the inverse sign. N for air has to be memorized, 1.0, and the glass, we have to look it up somewhere. I'm going to tell you it's 1.5 today. Normally there's a table that we look it up in. And then our incident angle was 42 degrees. We'll plug that in. And we'll go ahead and calculate that. I got 26.5. So now we're going to draw the refracted ray on the inside. So we'll put our protractor back up. Remember, the purpose of the normal line is where we're going to measure our angle from. So I'm going to line it up with the surface and the normal line, and I'm going to come around here to 26 degrees, and we'll put a dot there. And then I'll use my ruler to draw the light ray. Now I have to be careful that the light ray does not cross back out into the air, because it's going to bend again. It's changing mediums again. So it's only going to go up this far, and then we have to do another calculation to figure out where it's going to come out. Right at this spot, we're going to draw a new normal line. So let's put the protractor back up. I'm going to line the light ray and the surface up with the protractor, and then we'll draw a line at 90 degrees, so it is perpendicular. Now we have a new problem on this side. We have an incident light ray and a new incident angle here, and then we're going to calculate the refracted angle on the outside. So on the inside, we can put our protractor up and measure. This time we're going from the glass out into the air, so I'll call this angle in here theta glass. And if we measure that, we see that we actually get the same number that we had before. Looking at the geometry of this drawing, my two normal lines are parallel to each other, and we have a bisector here. This makes this angle and this angle alternate interior angles, so that angle has to be the same. So we're going to use the 26.5 that should still be in your calculator. Now we're going to use Snell's law to calculate the angle that it comes back out into the glass. So this time, we're going to calculate the angle that comes out into the air. So this time we're going to divide by n of air and then do the inverse sign, so it looks like this. So when I'm plugging my numbers in, the 1.5 is on the top and the air 1.0 is on the bottom. And then this was the angle on the inside of the glass, so we'll calculate the one coming out. Is this a strange coincidence? It happens to come out to the angle that we started with. Actually, it doesn't. We're going to draw in 42 degrees. So let's put our protractor back up and draw our line. It turns out for any parallel plate of glass, the light ray comes out parallel to the original light ray. And if I scoot that back, we can see the lines are exactly parallel with each other. All right, pause and copy. So we're going to measure from the normal line to the incident light ray. And on my drawing I have 55 degrees. We're going to use that for our calculations. So this is the angle in the air. We want to calculate the angle in here in the glass. So we're going to use Snell's law, solving for theta glass. We're dividing by n of the glass, and then we'll do the inverse sign like before. So we have 1.0 over 1.5 times sine of 55. This comes out to 33 degrees after doing the inverse sign. So the 33 is in here. Now we have to measure from the normal going this way. So we're going to put our protractor up here and make sure it's lined up on the normal. That's the whole purpose of the normal, is to measure your angles from there, and then we'll come up to 33. So this is the angle inside the glass. I forgot to label it again. Now when the light ray leaves the glass out into the air, we're going to need a new normal line. So I'm going to line it up here, and it has to be perpendicular to the surface. Now to calculate the angle on the outside, we need to know this incident angle on the inside. Now when the glass was parallel, like the upper problem, those two angles were equal. You can see in the drawing here that these are not equal to each other. So we're going to have to use some geometry tricks to figure out what this angle is here. Let's go to, this was the angle that we calculated, 33 on this side. So I want to figure out what the angle on this side is. To do this, I can recognize that the surface and the normal make a right angle 90 degrees to each other. And if this is 90 degrees and this much of it is 33, I can subtract those to figure out what the other side is. 57 degrees. The top of the angle, I know that all three angles are equal to each other, and triangles add up to 180 degrees, so this is 1/3 of that. That top angle is going to be 60 degrees. And then we're going to look at this green triangle here to figure out what this interior angle is, so then we can use this one in our problem. All right, so the next step is to find this one. Now I know the three angles of a triangle add up to 180, and I have 57 and 60 so far. So I'm going to do 180 minus 60 minus 57. That comes out to 63 degrees right here. To find the one in here, I recognize that this normal and this surface are perpendicular. This is a right angle, 90 degrees right here. So if this much of it is 63, then this one is going to be 90 minus 63 to give me my final angle, 27 degrees. Now this angle is inside the glass, so this is the theta in the glass, and we're going to be using good old Snell's law here to figure out the angle in the air. So this is the one that's backwards. We're going from glass to air this time, so I'm going to divide by n of air and then do the inverse sign on both sides. I'll do that down below. And this time the n of the glass is on the top and the air is on the bottom, and we have the 27 degrees that we figured out inside here. All right, so that comes out to 43 degrees, which is different than our original angle over here. So let's put the protractor up. Remember, it has to line up with the normal line, and then we're measuring 43 degrees from the normal coming around to here. All right, so this was our final angle from the normal to the outside light ray is 43 degrees. For your homework, you're going to be doing a similar problem to this one. So what I want to do is make a simple formula to do this inside triangle with. All right, so I'm going to number these angles 1, 2, 3, and 4. And look at my green colored arrow there. For angle 2, we figured out angle 2 using Snell's law from angle 1. Then we went from angle 2, we figured out that this angle was 90 minus angle 2. The angle on this side would be 90 minus angle 3. And the angle at the top was 60. I know that these three corners of the triangle have to add up to 180. So when I simplify these, I end up with angle 3 is 60 minus angle 2. So your homework problems, you're going to be doing Snell's law on this side with angle 1 to find angle 2. Then you're going to use this equation to find angle 3 from angle 2. Once you have angle 3, then you're going to use Snell's law to find angle 4. All right, that was